Okay, so now we're going to go on today, and we're going to do counting principle. The goal of today is to figure out how many outcomes are going to occur in a sample space. So first of all, I'm going to go back. We're going to review. What is an outcome? Some basic stats questions.
What you get from the income.
No. When I roll a dice, what's my outcome?
1 through 6, 4, 5, or 6.
1 through 5, 1 through 6, yes? So there's 6 outcomes, yes? If I come in this room and ask what grade you are all in, how many outcomes are there?
1, 2.
2. We've got junior and senior, okay? So those are outcomes. Outcomes are what happens from an experiment or a survey, okay? So what we're going to be doing today are using counting techniques to find those different number of outcomes. So I have 8 pieces of paper numbered 1 through 8 are placed in a box. 1 piece of paper is drawn from the box. Its number is written down and placed the paper. It is replaced in the box. Then a second piece of paper is drawn from the box and the number is written down. How many different ways can I get the sum of 12? Now, the big thing about here is I wrote the number down and did what with my piece of paper? I would put it back in so I can double things up, right? Mm-hmm. Now, if not replacement, if I don't replace, is it going to limit the number of things? Yeah. Yes. So we got it. When you were reading these problems, you need to know is there replacement or if there's not replacement. So I pull a piece of paper out. How many different numbers could I get? 1 through 8. How many different numbers could I get when I pull out 1 piece of 8? Thank you very much. Okay.
3.
I could get 8 different numbers. Okay, so I have 8. Yes?
Yeah.
I put it back in, and I pull it out again. How many different numbers could I get?
8.
8.
You're replacing.
Okay, but I'm doing the first thing, and then I'm doing the second thing. So how many different numbers could I get? Oh, we want 12.
Yeah.
I was just answering a vague question. Okay, so we want 12. I was answering a whole different question. Okay, so how can I get 12 with numbers 1 through 8? 4 and 3?
4, 8.
So I could get 4
Some.
and 3? Oh, some. Yep.
4 and 8.
6 and 4.
8 and 4.
7.
But I also could get 4 and 8. Yes?
Yes.
I could get 6 and 6.
5 and 7.
Or 6 and 6.
But you can't distinguish between 6 and 6 or 6 and 6 because I didn't say red paper, blue paper, did I? Did I? No. So there's only one way to get 6 and 6. Okay. What other way?
5 and 7, 7, 5.
5 and 7, 7, 5. Is that it?
Yeah.
Yep, we should have done 4, 5, and then 6. But that's okay. So how many different ways can this happen? 5. Okay. So sometimes we just write things down, yeah? Okay. Now what I was doing before was I was actually doing the same scenario. I have paper in there. I draw a number out, write it down, put it back in, draw a number, write it down. How many different products could I get, or how many different number combinations could I get is what? 64. So do you see how it's important to pay attention to what it's asking you? Okay, because questions like these are going to be on the ACT. You guys took it. They had questions like how many outcomes on things, did they?
Yeah.
A few?
So I just didn't answer.
You didn't answer them?
I didn't know how to do it.
Okay. I would assume you should have been doing this for the last several years, this kind of stuff, at least the counting. But it's really important to know because I'm going to tell you if this question was on the ACT, one of the answers would have been 5 and one of the answers would have been 64.
Why? What question on there?
Like if this exact question was on the ACT, your choices, one of them would have been 5 and one of them would have been 64. One of the other one would have been 16. How would they get 16? Just add 8 and 8. Okay. Another way, I don't know what they used to give like at least 1, if not 2 throw out answers. Now you're lucky to get 1 throw out answer on these. So, I'm trying to run into that. So just be careful that you're answering what the question is asking. Reading it twice isn't always a bad thing. Okay, this counting problem can be described by saying that the random selection occurs with replacement. And we talked about that with replacement and without replacement. So the last with replacement was 5, yes?
Yes.
Now I'm not going to replace. What's it going to change?
6 and 6.
The 6 and 6. I can't get 6 and 6, can I?
You can't use the
I
same
can
number
get
a lot.
4 and 8, and I could get 8 and 4. I could get 5 and 7 and 7 and 5, but I could not get 6 and 6 without replacement. So my options would be what then? 4. So it's important to know if things are replaced or not. Now it's not going to say replaced every time. I'm eating candy. Is it going to say replaced? No, because I'm eating it. It's obviously not replaced, right? They drink a pop and do something else. Is it replaced? No. So it's important to read. And like I said, I typically read these one time, picking out certain things, and go back and reread it before I start even doing the problem. Because I've too many times been answering the wrong problem because I'm not paying attention. Okay, what if there are too many possibilities to write down? So, if there are too many possibilities to write down, like we just listed them when we had 5 and it was all good, correct? But if there's too many to do that, we have the fundamental counting principle. It's multiply the number of ways an event can occur. It can be extended as much as you need to extend it. That was the 8 and 8. How many different combinations? There were 64. Would you have liked to written?
No.
Write down all those combinations? No. So the fundamental counting principle you should be writing down is multiplication. Okay. I don't know if you need all of that. It's the fundamental counting principle is the multiplying the number of outcomes. It is an and situation. This is happening, and this is happening, and this is happening. So your ACT scores are already going up, at least for 2 problems.
Not for Brad.
It's okay, Brad.
Mine went down.
Yeah, what'd you get in the one you took recently?
13.
Was that higher or lower?
That was higher than the one I took at school. Or that was lower than the one I took at school. I got a 15 on the one I took at school.
What about you?
33.
Was that higher or lower?
It was higher than my pre-ACT.
Yeah, that's the first time he's took it.
What is the M1?
Actually, it is higher than the one I took in 7th grade.
Well,
What'd
hopefully.
you get in 7th grade?
For some reason.
23.
How?
M1 is just a number. Like we had 8 and 8. It's just.
Probably.
Okay, we're good? You guys got it down? It's fundamental counting theorem. You multiply. That's it.
Actually, it's a principle, not a theorem.
Oh, sorry.
Yeah.
It's been 1v1 me and Fortnite.
Does your daughters play Fortnite?
I have no clue.
Do they have an Xbox or PS4?
No.
Okay, then probably not.
Do they have a Nintendo?
Okay, you guys good?
Yeah.
No.
They're definitely following up on the
What a
Nintendo.
robot.
Okay, can we stop?
Sorry.
Brad, let me know when you're good. I will tell you that until you get into more complex, that's usually the one you use most often. How many different pairs of letters of the English alphabet are possible?
I'm not a lot.
169.
Well, if there's 20...
How many letters are in the alphabet?
26.
26.
Is it?
Okay.
I don't know what that means.
Pair. You don't know what a pair is?
Oh, pears. I just was thinking are possible. That's all
No.
I thought.
Pairs.
I don't know. I was just
Okay, pairs are possible. So how many pairs? If I wrote the alphabet this way,
There's 26. So.
There's a lot.
There's 26 letters.
there's 26 letters, yes?
Yes.
oh well, no concerns that. I didn't.
Okay, so when I'm pairing them up,
Oh.
but then I compare this one with that one, and that one with this one, you guys want to start writing all those down?
Yeah.
We know that in
No.
biology.
So the first, when I'm picking When I'm picking a letter, I have how many to pick from right away?
26.
26. Okay.
25.
And then I have how many?
25.
Why do you have 25?
Because they're different pairs.
Because they're different
Actually,
pairs. Because
and
in the we have different pairs. So different means no replacement, doesn't it?
Yep.
Okay. So we have 26 times 25. Okay, so 20 times 20.
651.
What?
No, never mind.
I was going to do 20 and get 0, 2, 5, 520 plus 0, 5, 3, 130. I get 650. Somebody checking? You guys doing it?
That would be right. I know. I
Okay.
had it 26 instead of 25.
So there are 650 different pairs. Okay. Now the key word there were pairs, yes?
Yes.
And what? Different. If it didn't say different,
26 and 20.
it would have been 26 squared, right?
Uh-huh.
Which is 676.
Good job.
Jumpy.
Okay, this is small, but okay. Telephone numbers in the United States currently have 10 digits. The first 3 are the area code. The next 7 are the local telephone number. How many different telephone numbers are possible within each area code? Note that at this time, a local telephone number cannot begin with 0 or 1.
So it can't be 1-800.
That's not.
I was just joking.
Okay, so it said without the area code. So without the area code, so we're looking at how many numbers then? 7. Okay, so we have 7 places, right?
Yeah.
And in my head or on my paper, I do write those dashes because I'm thinking about placing those. It says, so how many different telephone numbers,
There's 8 dashes.
right?
These are 8 dashes.
Did I make 8?
Yeah.
Because I can't count, evidently.
Okay.
Okay, so let's see. How many choices of numbers do I have for the very first one?
9.
8,
No, 8.
7. I don't know. Somewhere in there.
9.
It's everything but 0 or 1.
Well, what are the digits? Of, what digits do I have?
4, 5, 6, 7, 8, 9.
You either have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
So there's actually 10 numbers between 0 and 9, yes?
Oh, okay.
Yes?
There are, but we can't use
Okay,
2 of them.
but we cannot use 2 of them because it says what?
To begin with.
They cannot begin
That's
with.
the first
Okay. So we have how many choices then here?
one. 8.
8. How many choices do we have here? 10?
10.
10.
9.
No, wait a second. If
It says different, but
It
I,
is-
I don't think that would mean like you have to use a different number of times in this situation.
Right. You're right. You're correct. But you can't use the same one you just used.
You can't.
Yeah, you can. Why not?
Definitely can. I mean, in real telephone.
Oh, yeah, because, okay. So how many digits do I have here?
10.
10.
10,
10.
10,
10.
10, 10, 10. Because it doesn't say anything about 0 or 1 after that, correct?
Yeah.
Now, could I start putting restrictions on there?
Yeah.
Like the first 3 numbers can't repeat?
Yeah.
And then are those 10 going to go down?
Yeah.
Okay, so now we have 8 times 10 to the 1, 2, 3, 4, 5, 6, right?
Yeah.
So that's 8, 1, 2, 3, 4, 5, 6. So how many telephone numbers is
8
that?
billion.
8 million.
Oh my lordy lord.
Now think about that. Lincoln has 2 area codes.
16 million.
I know, but I'm just saying, I'm not asking you what double that is. I'm saying think about it. Lincoln has 2 area codes.
And
What's the other one?
I don't know. There's 2 area codes. in Lincoln.
Do you know the first one? Then why'd you ask what the other one was?
Okay. Now I'm asking you, why does it? Because it didn't when I was a kid. It didn't have 2 area codes.
Because they wanted to. Because it's such
So there's so many
small
people.
city.
Because they.
Does Beatrice
yeah.
have 2 area
No.
codes?
Nope. Beatrice has
Or
1.
is that 2 zip codes I'm thinking
It only has one zip code also.
Two.
No,
No.
Beatrice has one. Lincoln has like 6 different zip codes.
Two for like one.
Hey, why did Lincoln have to go? Okay, think back. I'm old. I'm older than
They
dirt.
didn't have
You're
numbers
not.
past 5.
Guys, she types on a typewriter.
I typed on a
She did
typewriter.
PreCalc.
Okay, what was different 40? Well, give me when I was 6. What was the difference between 40 years ago and now?
You guys spun it on a
Yeah, I
little
was just gonna
dial,
say,
not.
Okay, how many phones did a house have?
One.
One. Okay, when I was a teenager, I begged my parents and I got my own line. So we had how many?
So you're
2.
rich.
So we had two phone lines for a house of 4 people. Okay, now how many phones do you have in a house of 4 people?
As many
Everyone
kids
has
as
Like
you have.
8.
4. Sometimes you have, like our house, we have 4 and we still have our house phone. Okay, so a lot more people are running around with phones, right? So,
But there's still not even 8 million people in Nebraska. So.
They have different
yeah, there
phones.
is.
No, there's not.
8 million people?
There's like
In the
6
whole
million.
state?
Yeah.
Oh,
There's
Look
237,000.
it up, Miss Mick.
I don't know. Okay, anyway, let's go.
But you also have to think about like.
Oh, wait.
phones,
No, that's
work
it.
phones.
That's it?
Okay,
We're done?
Yeah.